solutions to proving trig identities part 2, double angle, half angle. In each of these, we're going to use two things. The additive identity, so that's something that we have to know, so we should write that to the side, like that cosine of a plus b equals something. What does it equal? Right, cos A, cos B, minus sine A, sine B. And we're going to use a trick, right, that cosine of 2a equals cosine of a plus a. That's our trick. All right, that's the trick in each of these proofs of the double angles. So let's take a look at it. So cosine of 2a, I've got to make it equal this stuff. And, as I said before, there's the trick. We know that cosine of 2a, well, that's the same thing as saying a plus a together. And if I know that cosine of a plus a, I can use this formula here, this proof that we did, this identity. And instead of writing, well, let's see, this is cosine of a plus b, this is cosine of a plus a. So over here, I can write this stuff, but I don't need to write any b's. I can just write cosine a minus sine b, sine b. Oops. Sine a. Like I said, we don't need to write any b's, even though I did. Now, why is that? Because I'm plugging in a here, so I just need to replace all the b's with a's. Now, what is this? Cosine times cosine, and it's the same angle, so I can do this. Cosine and cosine is cosine squared, minus sine times sine, sine squared, and look, that's what I had to prove. I'm done. So let's look at this one. Again, same trick. I've got to show that this equals this, and I know that cosine of 2a equals cosine of a plus a, and that equals, again, cosine a minus sine a, sine a. And I got that from this same formula. So really it's just the same stuff. I hope that you see that. And again, we know this is cosine squared a minus sine squared a. Now here's the thing. What do I want it to look like? Am I allowed to have any cosines at the end? No, right? So I've got to find a way to get rid of this. Oh wait, we've got that handy Pythagorean identity. It's got stuff in terms of sine and cosine. So since this is a cosine squared, and I don't want it, right? I don't want it because this stuff is all in terms of sine. I can get rid of this cosine squared. How do I get rid of it? Well, I'll substitute it. So I can say cosine squared is the same as 1 minus sine squared. And if cosine squared really, if these are really the same, then instead of writing this, I can write that instead. So I'm going to write that. I'm going to write 1 minus sine squared a minus sine squared a. So I've got 1 minus, how many sine squareds do I have? Yeah, I've got 2 sine squared. So I've got 1 minus 2 sine squared a, and I'm done with that one. To do this last one, we need the tangent double angle identity. So you need to write down tangent of a plus b equals, right, this one right here. And what do you think the trick is? I should rewrite tangent of 2a as what? Yeah, same idea. It's literally exactly the same. Tangent of a plus a, and we'll use this thing now. So every time I see a b, I'll replace it with, right, because there's a b here. Every time I see a b, I'll replace it with this a. So tangent a plus tangent a all over 1 minus tangent a and tangent a. Now I've just got to simplify. Look, how many tangent a's do I have? Yeah, I have 2 tangent a's over 1 minus tan times tan, no, not 2 tangent, yeah, tangent squared A. And that is what I was trying to prove, so I'm done.